Hello everyone, welcome to our channel Simplified Computer Science Concepts by Professor Rutuja. Today we will be learning deadlock prevention techniques in distributed systems. So let us start. So for a deadlock to occur in a system, there are four necessary conditions that needs to take place. Now let us see which are these four conditions, and these all four conditions should be held simultaneously. First one is mutual exclusion, hold and wait, no preemption, and the last one is circular wait. When all the four conditions are held simultaneously into the system, then the system is in deadlock state. But if we are successful in avoiding at least any one condition, then the system will not be into a deadlock state. So how to prevent these conditions? Let us look into this. So the first one is how to prevent mutual exclusion condition. So there are two processes here, P1 and P2, and two resources, resource 1 and resource 2. P1 has been assigned resource 1 and it is waiting for R2, and P2 has already acquired resource 2 but it is waiting for resource 1 which has already been assigned to process P1. So this is a deadlock condition. But then resources are shareable resources and non-shareable resources. This mutual exclusion condition must hold for non-shareable resources. That is when mutual exclusion becomes true. So here, to prevent deadlock, we have to just do the opposite of the mutual exclusion. That is, if the resources are non-shareable, here to find out a solution to avoid a deadlock, we have to make all the resources shareable. So if we now make all the resources shareable, which means that this particular resource which was already been allocated to process P1 can now also be allocated to process P2. And a process P2, if wants to complete its execution, it requires two resources, resource 1 and resource 2. If all the resources which are required for execution are allocated to a particular process, then it can complete its execution. So process 2 requires R1 and R2 for completion, and it has been assigned to it, so process 2 can complete its execution. So here mutual exclusion is false. What is mutual exclusion? At any given point of time, only one process can use a resource. So here the resource is shared. So multiple processes can use that particular resource. So here what happens? Process P2 now releases resource 2 after the execution, and now this resource 2 can be allocated to process P1 for completion, which was where it was already waiting for resource 2, and now process P1 can complete its execution because resource 1 is already with it and resource 2 is now been allocated to process P1 after P2 releases it. So here no deadlock can take place. So this is how we can prevent mutual exclusion. Now the next point is preventing no preemption. The second condition is no preemption. Now how to prevent this? So first we cannot deallocate the resource. So that is where the no preemption was true. That means we cannot forcefully take out a particular resource from a process 2. It has to be the process which holds that resource, it has voluntarily to give up that particular resource. So here if you just check, here no preemption is true. Now what happens? The solution to prevent is to make the opposite, that is to preempt the resources. Wherein earlier we were not able to preempt the resources, the solution to avoid the deadlock is to preempt the resources. How we will do that? So here initially process P2 was requesting for resource 1 and P1 was requesting for resource 2. What P1 process P1 does that it releases resource 1 which was assigned to it earlier, and then process this resource can then be allocated to process P2. Again here if both the resources are available with P2, it can complete its execution and no preemption becomes false because we have forcefully taken out a resource from P1 and given it to P2. So here again in this case a deadlock can be avoided. So similarly when process P2 completes its execution, R2, which is required for process P1 for its execution, R2 and R1 both can be allocated to P1 and can be completed. So here no process is dependent on the resources. So by forcefully allocating a resource to a particular process, the deadlock is avoided. Then the third one is how to prevent hold and wait. Hold and wait is here we have to use a protocol which states that before executing a process, all the resources must be allocated to the process. So here P1 requires R1 and R2, and P2 also requires R1 and R2 for its execution. So what does this solution to prevent the hold and wait condition, what does this protocol says that if I want to execute a process, I need to first acquire all the resources that are required for execution beforehand. So let us say this process P2, this is just a scenario. It requires resource 1 and resource 2 and resource 3 for completion of execution. Then resource 1, resource 2 and resource 3. All the 3 resources that are required for its execution are initially assigned, and whenever before the execution, whenever all the resources are allocated, it will complete its execution. So before executing a process will be allocated all the resources that are required for its execution. And now process P2 can complete its execution, so no deadlock can take place over here. So this is how we can prevent hold and wait. Then the last one is how to prevent the circular wait. The circular wait condition is that P0 is waiting for P1, P1 is waiting for P2, and P2 is again waiting for P0. So this is how a cycle is formed. And so the solution to prevent the circular wait is that doing the opposite. That means we have to number all the resources, and if the process needs to access a particular resource, then it needs to send a request in receiving order. What do you mean by that? So here all the resources that are there, we will maintain a table which will number these resources into increasing order. For example, tape drive is having serial number 1, disk drive 2, printer 3, CPU 4. Now let us say there is one process P3 which is requesting for a printer whose number is 3. So what we have learnt over here, the process needs to send request in increasing order. Now process 3 also wants to access tape drive and disk drive whose priority or whose number is 1 and 2. But then process 3 will not be able to access 1 and 2. Why? Because it has already requested for 3, and the resources with less number cannot be accessed by that particular process. So the tape drive number is 1, which is less than 3, so it will not be able to access. Disk drive is 2, which is less than 3, so even disk drive will not be able to access by process P3. But then if process P3 wants to access the CPU whose number is 4 and which is greater than 3, so that request can be accepted. So it can request CPU. Again, so if by maintaining this type of a table, deadlock will be avoided. So this is how we can prevent circular wait. So I hope you have understood this concept. Thank you for watching the video. Please like, share and subscribe to the channel. And if you have any doubts, please comment in the box given below. Thank you everyone for watching.